Hello everyone, this is the Boomer Nerd, also known as George Tasker, and I'm going into part 3 of Future Ventures. The other day while I was looking into what I'm going to do in the future, I stumbled across various programming paradigms. And the paradigms that I'm looking at, I did some further research, and the particular question I asked this time is which programming paradigm is the most popular in software development. And it gave me, as my first article, a list of popular programming paradigms, and it has changed my thinking in terms of paradigms, because it would appear, as I read this, that there is quite a number of purposes depending on the paradigm that you use. Anyway, let's get into it. What is a programming paradigm? In simple terms, a programming paradigm is an approach taken to solve a problem. It is the basis on which programs and their elements are created. A single programming language may support more than one programming paradigm. For instance, Haskell is a programming language that supports the only functional programming paradigm. It supports only the functional programming paradigm, while languages like Ruby and Python, though they're built to favour the object-oriented paradigm, can support functional paradigm as well. Okay. I think this is what got me going down that particular rabbit trail the other day, because it said it supports multiple programming paradigms, including object-oriented, imperative and functional, or procedural styles. And I was wondering what these are all about. This particular one gave me the best. It speaks about the object-oriented paradigm, where everything in the program is treated as an object. Methods, closures, data structures are all objects in an object-oriented language. It's the most popular, so that answered the question which is the most popular, because its unique advantages like modularity, code, and ability to directly associate real-world business problems in terms of code. Yeah, I'd go along with that. Of course, one of the other things was we wanted easy maintainability. So the advantages of object-oriented programming paradigm: modularity of code, making it more reusable. 2, easier to translate business logic to code. 3, code maintenance is easier as the code is more readable, improve scalability, and enhance productivity. Now, one of the disadvantages is that applications tend to be larger in size. Reduced performance due to large application size. I remember we were using a profiler, an application profiler, and the whole purpose of that was to try and find out where the bottlenecks were in the code and try and, as best as possible, reduce or remove them altogether. And the whole idea behind that was to be able to then see which functions or which parts of the code were used the most often, and our effort then would focus on those bits of code in an effort to try and reduce the amount of work they did and speed up the overall application. Development requires specialised knowledge. If not well written, code can get messy pretty quickly. Well, messy code is something that you can expect in just about any language. The common vernacular we used back in the day was spaghetti code, and of course if you open a tin of spaghetti you can see how messy it can look. And of course, that really only matters if you want tidy. Of course, in the case of spaghetti, well, you only got one interest in mind, that's to eat it. Okay, so languages that support the object-oriented paradigm are Python, Ruby, Java, C++, Smalltalk. They don't refer to Borland's Object Pascal or Delphi, probably because I think it's dropped away in popularity, which is a bit of a pity because it was quite a decent language, but there were certain features it did not contain, which C++ does, and I suppose that could be part of the reason why there could be a problem there. For example, C++ supports multiple inheritance, whereas Delphi and object-oriented Pascal did not. Okay, functional programming. Functional programming paradigm has been in the limelight now for a while since JavaScript. Functional programming language has gained more popularity recently. It is a style of programming with pure mathematical functions that makes use of functions to transform data from one state to another. In the functional programming paradigm, functions do not modify any values outside the scope of that function, and the functions themselves are not affected by any values outside of their scope. Due to a lack of shared state, functions require variables to be passed into them explicitly as parameters. Return value of function will remain the same as long as the parameters are not altered. For example, the function add 1 and 2 will always return 3. Advantages: code is always precise and succinct. Predictable output makes testing easier. Succinct code implies faster execution of programs. Implementation of concurrency and parallelism is easier. Shortcomings of functional programming paradigm. Immutable variables imply the need for the duplication of data, which can become memory intensive, especially when creating recursive functions. Difficulty in creating code that is scalable, and integrating functions to create a program is harder than you think it is. And in this case, they refer to languages that support the functional programming paradigm being Haskell, OCaml, Scala, Clojure, and Racket. And I don't know too much about those. I think if we were to go back to TOB, let's have a quick look back at TOB. Okay, we'll go back in here and we look at the various programming languages. So, can we find Haskell? No. We find ratings. Delphi Object Pascal is climbing back up again. That's interesting. Swift, no, none of those names are there. Assembly language, which is apparently imperative, is gone up by 1%. And then there's all of our graphs down here. Other programming languages. Oh yeah, okay. Looks like Rust is going to stay at the bottom. Based on what I have heard, that's exactly where it should stay, especially if you're open source operated. Haskell, oh yeah, there it is. Haskell. Let's start. I'll just go back and take a quick look at there's OCaml, Scala, Clojure, and Racket. Is there OCaml here? No. Is there Clojure? Yes, it is. There it is, right there. What about Racket? One way to find out. Okay. It only appears once. It is mentioned. They're only listed in alphabetical order. Okay. Alright, and it doesn't indicate that it's there. There's OCaml. and OpenCL, so I don't know, maybe it's OCaml. One way to find out. No. And it only appears once. Okay. Alright, so they mention some of these by name, but they don't actually seem to do anything with them. So in other words, those languages, even though they're there, are very specialist if they get used in industry at all. Imperative paradigm. Okay, the imperative paradigm. Results are achieved using sequential statements that modify the state of the program. This paradigm requires a program to explicitly code every single statement necessary to achieve the desired result, which implies that the option of using pre-coded modules is unavailable in this paradigm. This paradigm was introduced when only primitive languages like assembly and Fortran were available. The output of imperative programs are usually executable files which execute really quickly, since CPU instructions themselves are imperative in nature. Advantage of imperative programming paradigm: statements are easily mapped to the CPU ISA instructions, so it's a bit like assembly, which is close you can get to the underlying hardware. Executes really fast, especially in the case of primitive languages like assembly. Step-by-step specification of the program flow offer greater control over the outcome of the program. Shortcomings of the imperative programming paradigm: no modularity. Maintenance is a nightmare. Level of abstractions can be generated, but it's limited. Order of execution of code, presumably, really important. Okay, now the maintenance is a nightmare is going to be an issue, and this is probably why they have chosen to leave programs that are based on this paradigm in a fairly down near the bottom. Ada, Algol, Basic, Pascal, Fortran. I've kind of thought of those as being procedural. Should go back up there and take a look. See, imperative is these fellas here. Ah, yes, procedural is one of them. Okay, then object-oriented parallel processing. Good. Okay. Let's go back up there and look at it again. Imperative is, so these procedural, object and parallel processing are all coming out of imperative. That's interesting. Let's keep going. A declarative paradigm. The declarative programming paradigm is an approach where the output of the program is defined by the programmer without defining how the output is to be achieved. The control flow of a declarative program is implicit. In declarative programming, the language implementation is responsible for generating output prescribed by the programmer. Declarative programs use expressions instead of statements to achieve the desired output. An application of the declarative paradigm has limited scope. It is used mainly to develop domain-specific languages and not programming languages. Okay. One of the things that seems to happen here is this could be how compilers are developed, because we'll take a look at it a bit further. Advantage of declarative programming paradigm: conceals lower level operators to help focus on the logic of the program. Code is almost very compact as only the output is defined. Better code readability and code reusability. Shortcomings: the developer has no control over how output is achieved. Does not have all powers of a programming language. Okay, so that is specialist, because the languages that support declarative programming paradigms are SQL or SQL, as some people say. Regular expression, so that's essentially text searching, and HTML. And HTML is more about the way data should be displayed on a page. So when I look at this, it would seem to me that each of these particular paradigms is there to achieve a particular purpose. And so it really comes down to what do we want to do to look at before we try and choose which application or whatever we want to choose. Okay, so that one there was, I found, fairly informative. So I'm going to blow away most of this stuff, which, while it is helpful, it didn't. It was that article about comparative was pretty handy. So it's helped to solidify my thinking. And most of these paradigms, as one person said, are all about setting up constraints in programming. With assembly, there are virtually no constraints. So it's really about control of program flow. And this is necessary because with structural and object-oriented programming, you're trying to make it easier for somebody who has to maintain the code you develop. You make it easier for them to get to and actually maintain and possibly find the bugs that are in the code. There was a limerick, and it sort of went like 50,000 bugs in the code. I don't know if it will bring it up. But the basic premise behind it was that there are 50,000 bugs in the code. You went, here we go. It's very similar to this particular graphic, which I personally found. 99 little bugs in the code, 99 little bugs in the code, take one down, patch it around, 127 little bugs in the code. Okay, so yeah, they did, whoever was using it back in the day, this was about 20 odd years ago, they had their system giving us 50,000 bugs in the code, and I think it was 50,001 bugs in the code by the time they did the patch and I think it goes to the tune of dun 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 dun. Yeah, 99 little bugs in the code, 99 little bugs in the code, take one down, patch it around, 127 little bugs in the code. Yeah, so oh yes, used to be 9 green bottles, that's what it was. 9 green bottles are sitting on the wall, 9 green bottles are sitting on the wall, and if 1 green bottle should accidentally fall, there'll be 8 green bottles are sitting on the wall. And of course, my mother used to sing through the whole song. Then one day, I don't know whether she was sick of it or it was just her creative mind. She was very creative with some of her expressions, and I think I picked up some of that from her. And right at the end of the song, she goes, "Smash, bang, crash," and I don't know why, but it really hit my funny bone at that time. Still remember to this day how I found it so freaking funny. Oh dear. Okay, alright, we're going to jump out of that. But yeah, one of the reasons for structural programming of any kind using these various paradigms is an attempt to try and make sure that there is going to be a way of debugging the code, especially by software maintainers who have to come back and look at what the original developers have done. Once the original developers have put the code in, you can have code that's virtually unreadable. There's been talk of so-called self-documenting code, and some people manage to do it, others not. And I'm inclined to think that maybe somebody who's good at writing books may well be able to be better at writing code for maintainability purposes than someone who is just a super duper awesome developer. And so it really depends on where you want to go. Okay, so I was looking at Python. Python can be used for desktop applications. I think I pointed out the Gourmet application the other day. I was a little bit disappointed when it stopped working on our systems, because what had happened was that they'd been running on Python 2.3, and then the version of Python that came out was 3.0, and so as a consequence their app would no longer run because the things had changed significantly. So if they were going to get it to work again, they had to do quite a bit of work on upgrading the code to run in the new 3.0 platform. So one of the things that I think is going to be necessary at some stage is to possibly take a look at Python to some degree. I wonder if Python is in Android. Let's find out. Okay, Python for developing Android apps. How to develop Android app completely using Python. So somebody's asked a question, so let's go and find out, can it be done? Build a mobile application with the Kivy Python framework. And best Python frameworks. Oh, it looks like it's okay. Alright, let's go and take a quick look and see. Close. This question does not speak. It's not accepting answers. Okay. Alright. Okay. They have a bulldozer. Have document. Oh, Kivy framework. Okay. You use either Java or Kotlin. However, as others point out, there are third-party app builders or frameworks. You can use Python like PyMob or Kivy. Your games completely developed in Python using Kivy. It's a Cointext example here at Google. Source code game, blah blah blah, wrote blah blah blah. Okay. So 4 answers. Now, it is feasible in pure Python. You've got to use Beware, suite of Python tools. Okay. Android's preferred language of implementation is Java. So if you want to write an Android application in Python, you need to have a way to run your Python code on a Java virtual machine. This is what VOC does. VOC is a transpiler. It takes Python source code, compiles it to CPython bytecode, then transpiles that bytecode into Java compatible bytecode. The end result is your Python source code files are compiled directly to Java class file, which can be packaged into an Android application. Okay, but why would you want to go to all of that effort? That's the thing that gets me. When was this question asked? That's the other question. 3 years, 6 months ago. Okay. Viewed 270,000 times. Okay, so this is one of the frameworks which you can use. Okay. So the question that some people might ask is, why do I choose Android for trying to develop apps as opposed to, I think it's Object-C for iPhones? The reasons are more political than anything else. Back in the day when I first saw the iPhone come out, they had very close control on all of the source code. In fact, I think the iPhone is a closed source system, which means that when you do write code for it, it's a bit like writing for Windows. In Windows, you can't see what's going on, and you are basically controlled by the idiosyncrasies of the operating system. Whereas with Android, there's a lot more freedom. Not only that, but Apple only allow you to have apps running from their App Store repository, and you have to go through a lot of hoops. At least with Android, you can say, okay, I've created an APK. For some reason or other, Google doesn't want it on their Google Play system, so I can just set it up as an APK, and people can download it directly if that's what it comes down to. So yeah, there's a lot more freedom there. I mean, at the end of the day, my attitude is, if I buy a piece of hardware, then I should have the right to use it how I want. I mean, if I buy a car, I get to decide when and where and how I drive it. Now, it's possible that I might run through a school zone at 50 kilometres an hour, and the cops will pull me up for it. This is during the actual, the school zone time, and they'll spank me for doing over the speed limit. Well, but I still have that capability of doing something I shouldn't do, if that's what I wanted to do. But yeah, there's quite a lot of freedom. The freedoms, of course, are going to slowly decline as the technology increases. But back in the day, once you got a machine, you could do just about anything you wanted with it. And so, yeah, I prefer the freedom that open source and an open source based system offers to the user. For me, freedom is better. I take the responsibility for the and also suffer the consequences for any of the choices that I make. I'll give an example. About a year or two ago, I was doing some delivery work, and I pulled up at a fuel station, and after I got about to $40 or $50 worth of fuel in, I suddenly realised it was the wrong fuel that I was putting into my vehicle. Now, I bore all of the consequences of that, and the consequences were that I had to pay for the fuel that I had put in by mistake. That hurt. And then I had to bring in a tow truck and get him to take me to a mechanic, who then drained all the fuel, and I had to pay for all of that. That was expensive, but I bore all of the consequences for the silly choice I made. I had the freedom to make that choice, yes, and I bore all the consequences for that bad choice. And I just hadn't been paying attention at the time. You can rest assured, the mechanic told me, they said they get at least one of those a week, and they said they've never had any repeat customers on that particular matter. And you can rest assured, yes, I think there's a certain amount of truth in that, because these days I'm always very cautious, especially when I'm driving diesel vehicles and petrol vehicles, as to making sure that I put the right hose into the fuel tank. So, yeah. So the thing is, I prefer the freedom. I prefer the freedom. I prefer the risk, because at the end of the day, we have to be able to measure risk ourselves and decide what we are going to do. Anyway, so let's take a look. So this is Python. Has many dependencies. Recommends sorting to Python virtual environment. Okay. Alright. Now, I've never worked with virtual machines. I'm not sure I'm persuaded of the... I might go into looking into setting up virtual machines at some stage. I mean, this particular machine certainly has the facilities for doing so. Okay, so this is a whole bunch of instructions on how you can use Python for writing code. I think I might actually ask the next question. The most popular uses of Python software development, because it seems like it's what is Python used for. Okay. Data analytics, machine learning, and even design. Sounds like it's almost a perfect, sorry, not perfect, it's almost a general purpose language. It's a general purpose programming language that can be used for many things. Okay, alright. Successor to the ABC programming language is a high-level dynamically typed language developed by Guido, as opposed to statically typed. Okay, yeah. Intervening use Python become a favourite of tech industry used in a wide variety of domains. The language developed in its modern form in the early 2000s with the introduction of Python 2.0. Its basic operational principles remain the same. Python code uses the object-oriented paradigm, which makes it ideal for writing both large-scale projects and smaller. Okay. Says it's easy to learn, follows organised structure. The most popular uses for Python and discuss why it's a perfect language for anyone to learn. So web development, calculators, operating systems, desktop applications, fintech. What's fintech? Financial tech, is it? Well, that's one way to find out. Search Yandex for fintech. Financial technology. Figured as much. Okay. Alright. Reason for its popularity is Python's usefulness in applications like data regulation, analytics, risk management, and quantitative rate problems. But there are tons of Python tools make it the perfect language for fintech and other finance applications. NumPy, SciPy, okay. They have a integrated development environment, if I remember rightly, and it's got that rather quaint name of Boa Constructor, which I think is pretty cute. Is Python object oriented? Oh, yeah, well, I think it is. Here, a few examples of most prominent. Okay, right, mobile apps. Let's go to many mobile app developers. It's just as useful on iOS and Android as it is on desktop. Yeah, but doesn't Java do the same thing? There's a long list of mobile applications built using Python getting longer. Popular programs like Instagram are mainly written in Python, so clearly it's a great way to start off in mobile development. Well, the thing is, I imagine that they have what might be known as a hardware abstraction layer. So most of the functionality gets popped into that, and then you've got a thin interface upon which the rest of it all works. Data science, oh come on, go away. Keep reading, thanks. Data science, business startups, learning how to code. It's usually best to start with simpler coding languages. If you're operation, okay, so it's a simpler coding language, all right. What's it like for efficiency though? Say compared to Java, is there any way of measuring it? Right, okay. Language produces faster executing code, Python or Java. Which one is faster? Alright. So I'm trying to figure out why Python is quicker. Python or Java. All the power, not all the costs. The compiled versus interpreted. Both Python and Java live in the world between compiled. Okay. The degree to which Python's compiled depends on the tools outside the real world. Now, the speed is different due to dynamic Python versus static bindings. So in Python, once you call a function, takes a function name as a string and look up that string in the dictionary to find the actual function to call. It has to do this every time because every object might be patched with different functions at runtime. Java, on the other hand, very quickly find in its virtual methods. C++ is, and C is even faster since it addresses functions known at linker time, unless you opt to use virtual functions. Both Python and Java execute on top of simulated real computers, but the static typing and sophisticated tools make it faster at runtime than Python. Okay. Right. So in other words, if we're looking for speed, we want Java. If we're looking for simplicity of prototypes, Python is the way to go. But these days also, it depends on what you're trying to do, I guess. If you're trying to do something that involves lots of calls to virtual dynamic bindings, then it's going to slow things down. So obviously you'd want to do something that makes it less of a problem. So I guess it's... So they got other questions here. Why is Python faster than Java? Huh? Python 3? Is that for real? When did this question get asked? So they got asked in 2020. Why is Python 3 faster? Well, let's see when that question came out. 2019. On Python 4, 1.5 seconds, of course. To get a real number, we need to model. Okay. What? some code computing how many software engineers it takes to change a light bulb. It took 2 seconds on Python 4 and it took 1.5 seconds on Java. Of course, to get real numbers, we need to multiply these with version numbers. 2 times 4 equals 8 is less than 16.5. Oh, okay, alright. So in other words, bogus claims. It's got Python 4 out. Not the source code like in Python. Oh, okay, right. So someone gave a bit of a serious Python 4. A few trolls coming in to answer the question. Yeah. Okay. Alright, so there's a few, yeah. Okay, so someone's attempting to get, okay. It's Python written in C, not to be confused with Python. It's the fastest one, however. PyPy, written in Python. A huge event is among the top reasons why Java is faster than Python. Just-in-time compilation, which basically adds a JIT compiler to the interpreter. This makes it several times faster than Python code interpreted by CPython, but still not fast enough. In addition, Java signs concurrent tasks due to Python being affected by the global interpreter lock, which makes it impossible by a single interpreter process to execute multiple threads in parallel. However, we do have Jython, a Java-based Python interpreter which doesn't have GILs, as far as I can remember. But even then, Python needs to go through Java and be okay. Alright. So it looks like if we want to do any significant stuff as far as mobile apps is concerned, Java may be the better way to go. And then we've got Python versus Java. Java statically typed, write once, run anywhere, designed to run on any platform. Okay. Python is dynamically general purpose programming language. Okay. Don't have speed, don't have semantics. If you want to compare speed, you must choose implementations. Okay. Dynamically typed, so it's probably good for prototyping, quick and dirty stuff, which is probably one of the reasons it's okay. So we could ask the question, why has Python become so popular as a development language? Populated, very popular, easy to learn and use, complex, includes a learning curve. Well, yeah, look, I did Delphi, Object Pascal, and I found I had a bit of a fiddle with Java. Apart from just having to learn all the framework mumbo jumbo and the documentation, it's pretty much the same. The implementations were pretty much the same. Slower than Java and various implementations, relatively very fast. Cross-platform, yes, thanks to the JVM. Back-end frameworks, Django Flask, Spring Blade, machine learning libraries, okay. Game development engines, that, okay. So it really depends on what framework, what you're going to do, so what frameworks you're going to want to do. Of course, Java has its own class libraries as well. Okay. I'm going to now put the question. Okay. Why is Python so popular as a programming language? Okay. Yeah, 2020 will be alright. Don't know. Oh, that's back in 2019. Go Skills looks like a headhunting place. Great way to learn how to code. Okay, alright. So probably quick and easy for the average Joe Blow to understand. Came out in 1991. Okay. So this gives the figures for 2019, and it was 10% at that time. I think now it's around about 30%. We'll just go back and have a quick look. So Python is the most popular at 11%. What was it back then? 10%. There's been no change in popularity compared to the previous month. So when you look at it, we've got Python here. So it's been a slow and steady climb. Okay. Python popularity seeking for reasons. Increases productive development, comparatively easy by terms of learning and working with it. Speed of application written in Python does not negatively affect user experience. Now, in other words, the computers are powerful enough now, and also presumably phones and that. I mean, the amount of power packed in my phone. Come to think of it, I should go and grab my phone. I might pause the video in a moment to go and grab it. The only trouble is it tends to go off and interrupt my doing video. Okay. Python allows businesses to enjoy faster time to market. Benefits of Python beat the speed problem. Okay, let's take a quick look at that. In most cases, language suitability for a certain project is of high importance and speed. When it comes to Python, it has a huge community. So hiring Python developers is quite easy, both for development and maintenance purposes. Okay, there's a wide range of... Okay, so the amount of actual programming support is quite significant. So let's go back up. For some reason or other, it didn't go away. Benefits. All right. Now, in addition to the above mentioned benefits the programming language brings to businesses and developers, Python has much more on offer. As we've mentioned before, the language can be used for the development of nearly any sort of system or application. Here's where the key reasons for popularity of Python can be found. It's perfect for the creation of such trendy technological solutions as the Internet of Things, IoT. Okay. Data science and AI-based applications, so general purpose. IT developers take advantage of Python quite often. Even though Java is still considered by many as the top technology for such purposes, Python programming popularity is largely driven by the rising trend for connected devices, related software solutions. Language opens up space for the creation of code that ensures communication between sensors, displays, robots and other devices, as well as allows sending and receiving data through different communication channels. Even though not all devices support Python, the majority of them do. There's also an option for programmers to utilise MicroPython, which offers the advantage of extra simplicity and significantly speeds up development. Okay. Alright, so I guess it's got something to do with ease of learning and the multiplicity of things to which it can be put to. Introduction to the world's favourite programming language. Okay, so alright, so this is a journo's take on it. Right. Kill cancer. Yeah, okay, this is a journo's. Be a bit careful what I. Yeah, okay, web developers, okay, data scientists, teachers, machine learning, the pros. Simple, okay, so easy, so basically easy to learn, easy to organise and analyse, awesome Python, awesome libraries alive. So what are the cons? Python is slower than other languages, it's weak in the mobile computing world. Uses space, design restriction, runtime errors. Python is a baby language of the programming world. Some programming snobs have likened Python to a baby language. Well, yeah, okay. Yeah. Well, okay. What I'm going to do is, I think I'll probably stick with Java for now, given my former experience. But I'm going to just do a little bit more research on Python before I move on. So, Ubuntu IDE Python. There you go. How do you like that? Must have known what I was trying to look for. Top 10 Python IDEs for Ubuntu. When was that written? You've got to watch this. We'll go for search tools. Past, no, I want more than past month. Why can't they give us past year? That's about as useful as tits on a bull. And then we'll hit the search again. Okay. So it's showing these coming up. So Vim, yeah. Look, if you're into text-based screens, yeah, but PyCharm and Eric, open source integrated. That's more like I want. I'm going to close the door. I'm getting too much interruption from voices coming elsewhere in the house. That's a bit better. You can still hear it a bit, but I don't think it will be quite so bad now. Piezo, open source framework based on Python, so it's written for itself. Interactive, no compromise with its features. Syntax highlighting, indentation, drop files. What are these like? Okay, so it's telling us to get these. I mean, some of these look alright. Auto completion. Emacs. Interesting. Wonder why it's so powerful. No idea. Atom. Oh, it's an open source text editor. PyDev. Eclipse. Right. It offers features code analysis, graphical debugging, code refactoring, It's part of integrated Eclipse has a very good user base. You need to install Eclipse from the Ubuntu software and add PyDev plugin to it. Wing. Do I have PyClips on the system? I'm going to take a quick look. Yep, I do. Eclipse. Alright. Okay. Wing. 90 developed by Wingware. Python programming. Auto completion, auto source mode, cloud navigation, as well as remote debugging. Download Wing package from here. Doesn't really tell you much about it. Yeah, no, it's a commercial. Thon. Okay. Right. Alright. So idle. Haven't heard of that one. Yeah. VS Code. Okay. Code box. Code.io. Genie. PyCharm. All development features. So presumably it may have let's see, smart code inspection, code completion, the error effectively, offers excellent navigation, can generate automated code, and an integrated debugger. Okay, right, test runner and integrated debugger. Yeah, you need those. So PyCharm would certainly get on my short list. Okay. Alright, let's see what we can find in the way of PyCharm. Oh, there it is. Now that's interesting. Let's okay, where does that come from? Flat up. Oh, 1 gig in size. Damn. Okay, so it's saying don't install FlatHub. Okay. Somebody doesn't understand why Flatpaks are so big in size. Okay. Alright, let's take a look at this one. Yeah. This is a snap. What do snaps do? 2 community editions. What's the difference between that and the professional? Proprietary. There you go. And that's also Snap. Well, one of the other things we can do is go into Synaptic. It's suggesting that we don't install it from FlatHub, so go and see what Synaptic can do for us. There you are. Okay. Alright, let's do a hunt. Does not find it. How interesting. Alright. Let's see what Get PyCharm is telling us to do. SourceForge. Oh, how good. Come on. What's going on here? Oh, that's better. Try Eclipse Portable. Okay. Right. Well, let's click on download and see where that takes us. Latest download. This is your download will begin. Okay. Well, that's as useful as tits on a ball. It's coming down as a Windows exe. You're no fun. Just get PyCharm. There is such a thing as PyCharm, but oh dear, what are we going to do? Right. That's a bit of a nuisance. Okay. Now this doesn't really tell us. Okay, PyDev, open source, things for Eclipse. Okay. Spider, scientific programming. Okay, right. So it's a specialist development platform. New Emacs, Vim, nah. No. Okay. Yeah, no, I think we're going to be stuck with PyDev by the look of it. As we would be bringing in PyDev on Eclipse. Okay, let's go and bring in Eclipse. Been a long time since I've run this platform. This is a bit of a nuisance. Okay. We'll continue. 2021-09. So it's got its own web page. I mean, its own browser. Ooh. So what's this? Jet to Java. Java Development Kit. That's what I was talking about before. The Java Development Kit. Yeah. Java Runtime Executable. Okay. Now, so that's already in here. Incubating components. 2021-09-10. So that must have been when it came out, which was about a month or so ago. Okay. What's this banging on about? Yeah, probably something to do with. Okay. So we want a new. Okay, so new Java project. All right. Okay. I'll have to take a look at how to install Python in it, because Eclipse is supposed to be a multi-programming development environment. It's supposed to allow you to do PHP development and Python development and Java. It was written, it comes with Java included straight off the bat. Okay, so I'm going to blow that away. So if I decide to play with Python, okay, now Android IDE Ubuntu, whoops, and I've just noticed I've gone over an hour, So what I'll do is I'll stop here and then we'll continue on with the question Android. So we'll get back to that in a moment. But right now I'm going to stop the recording. This is George Tasker, your Boomer Nerd.